Okay, I want to jump to a log equation because some of you guys have problems with that on the logs test that we had a while ago. That should be around number. No, there's one here. There aren't questions. Better be one here. I'll be really disappointed if not. Actually, there was. I made an answer for it. Yeah. So let's talk about 77 and maybe 79. I think those are two good ones to talk about. So starting with 77. God bless you. So definitely expect a log equation problem on the final, which means you need to know your log properties. Okay. Now, when you look at this equation here, what does your gut tell you that we should do first? Because your goal is to use properties, right? To make it, and actually you want to get down to one log, right? Right now you actually two logs. One log is better than two, right? Because it makes it easier to solve when you have one. But, and I see a minus in between. You guys know what that minus? Okay, but before even that, you see two out first. What does that mean? All right, you have it back, good. Move it back first, because that's going to make your life much easier. So that'll be log base 2 of x squared, very good, minus log base 2 of x plus 3, of course, equals 2. Okay, now I can do the division, right? Now if it's a plus, do multiplication. If it was minus, do division. So you got this. So just by moving the 2 back, I'd say that's worth a point on the test. By doing this, probably worth another point. The next one's a big step. It's a huge step. We have to get rid of the log because the whole point is to get x by itself. So we can't have the log there. It's got to go away. How does it go away? What do we do? How do I make it go away? X squared of x plus 3 equals what on the other side? What will be on the other side, guys? This is a big one. Okay, I'll give you guys a big hint. What does that mean? Yes, good. That's how you get rid of logs. Remember, the whole essence of a log is this. Log base px equals y. It is the same thing as x equals b to the y power. It's the same thing, right? So whatever this is, that expression stays where it is. The subscript gets risen to the y power. That's it. So that's 4, right? Totally, it's 4. Now this becomes a rational equation. So there's still yet more steps. I'll multiply both sides by x plus 3, right? Bless you. So you have 4x plus 12. Does that make sense what I just did? I cross multiplied. Because think about it. 4 is 4 over 1. Cross multiplying just means you multiply both sides by something, which is fair treatment, right? If you do what to each side, same thing, right? That's all good. In this case, I multiply both sides by x plus 3, but I also multiply this one here to the x squared. Sure, whatever. And then you have to factor, right? Or move everything to one side. So I'm just kind of going in circles here. My apologies. X squared minus 4x minus 12. And I know you guys can factor this. How do you factor this? X and X, and what goes next to them? Not quite, because you have -4 in the middle. Do you guys see how that works, right? Right? X is 6 or -2. Now you can't log negative numbers, so the -2 is not okay. So you're gonna stick with 6. So from a point perspective, definitely moving that 2 is worth a point. I know I erased it. That was worth a point. Doing the division. There's probably a point or two. I'll say 1 point for now. Cross multiplying worth another point. And then doing the factoring and solving. So probably something like this would be worth about 6 points, I'd say. That's kind of fair. Just showing all the steps to be very clear about that. Okay.
Wait, is it 2 100-point tests or 250 points?
It doesn't matter really because it's in the grand scheme of things for 20%. I mean,
yeah, I'm just thinking about like the size of the packets.
I mean, I'm making it worth 50 each. That's how I'm going to record it. Overall, be 100 points. So I don't know. Okay, so you have a chance to work on some of these other ones later on. Okay, we need to talk about trig identities. That's been a while, and you will have to know your. I don't think we provide. Actually, let me freeze the screen and pause the recording because I'm actually pulling up a copy of the final. Okay, but I mean, because there's some identities that might be hard to commit to memory, but I think we're gonna keep it pretty straightforward. We're not gonna do anything that's too out of left field. Okay, identities. Here we go. Yes. Okay, perfect. Um, let's do 25 and 30. I think those are two good ones. All right. Okay, so usually the trick here is work on the side that's most complicated. And I'm actually going to make that a requirement. You have to work on just one side because otherwise it just gets really messy. I think it's pretty clear. Actually, I shouldn't say that. I was gonna say it's pretty clear left side's more complicated, but no, I think you can approach it either way. I think either way is fine.
By the way.
Oh, thanks. All right. Sorry. Yeah, so here we go. I'd say working on the left side is probably better for 25. So what I'm going to do, actually, this is a really easy one. I don't know why I chose this one. I'll do it. I already committed to it. So anything that's not sine or cosine, make it sine or cosine. But consider what's on the other side too. Like, so this is the problem. Some people get so caught up in like the formulaic way, like, okay, well, I gotta change like, anything that's not sine or cosine to, sine or cosine, right? Which is, yes, you want to do that. But really, what's the whole essence of this problem? Make the left side, right side the same. They almost look the same, don't they? If that denominator is gone, they are the same, right? Can I make that denominator go away right away? How? I can't. How? What should I do to that cosecant? Make it what? What is cosecant as an identity? 1 over what's sine times 1 over sine? What happens if you sine times 1 over sine? They cancel. And it's done. It's literally a one-step process. Well, 2 steps, I guess. Right? And then those go away.
So are you gonna get a formula sheet for you?
Hey, I'm gonna verify that. Let me get back to you guys on that. You later today by tomorrow. If I do find it today, I'll email you guys and let you put it as an update in Schoology. Because I did look at the email correspondence back and forth, and they said they're attaching a form sheet, but I didn't see one there. So let me find out what's going on there. And that's it. It's verified. Done. So do keep in mind what you're trying. What's your destination? Your destination is cosine theta minus sine theta. So yeah, there's no reason to change this cosecant theta. Keep it as is. But that cosecant theta at the bottom, yes, I wanted to change that because it'd be nice if that was just one. Okay, let me try another one because that was a little too easy. I think you guys need to see a more complicated one where sometimes the steps are not as obvious. Okay, so for 27, it's pretty clear you're gonna work on the left side. I think that's pretty obvious. What's also obvious is that you need to make these two fractions into one. If you're gonna make two fractions into one, how do we do that when there's a plus or minus in the middle? You find the LCD, right? What's the LCD here? Yep, cosine times 1 plus sine theta. So whatever each denominator is missing, that's what you got to do. So I'm going to multiply this by cos theta, and multiply this by 1 plus sine theta, 1 plus sine theta. Then you have to go through the motion. Now, I'll be honest, I don't know what's going to happen because I can't see all these steps in my head. I'm not going to try to do all in my head. I'm just going to go through the motions, but I feel this will get me to this pathway. So you're kind of in the weeds right now. That's okay. We'll hopefully we'll get past the weeds and see this beautiful vista or field, right? So yeah, so I have this 1 plus sine theta times cos theta. And that's going to be 1 plus sine theta to the second power plus cosine squared theta. Okay, now I think I can kind of see what's going to happen. Because I have to FOIL the 1 plus sine theta, right? When I FOIL this, what's going to happen when I FOIL this? So what are you going to get how many terms do you get when you FOIL 1 plus sine theta itself? You have 1 plus sine theta times 1 plus sine theta. Let's do it off to the side. That might be a good idea. Sometimes that's not such a bad idea. So your work is a little more clean. It's kind of like, for example, I mean, I'm trying to think of dumb analogies here, but like if you're working on a car, I've never really worked on a car, but if you were working on a car, like maybe building the engine or whatever, you usually take one part of the car away, you kind of work on that one part, then you bring it back in, right? It's kind of what we're doing here, right? We're taking like one part of this out of the equation. Let's work on it and bring it back in. If I work on this 1 plus 2 sine theta, because you have sine theta plus sine squared theta. Does that make sense how I foiled it? So you bring it back into the mix. So I'm going to erase all this, bring it back into the mix. So it's going to be 1 plus 2 sine theta. Now, hopefully you can see what's going to happen next. What's going to happen next, guys? What does this become? This is an identity that you should know. Even my friends who are in the 40s who have done math, they're like doctors or lawyers or whatever, or other professions. They still remember this. What's sine squared plus cosine squared? It's a Pythagorean trig identity. We should know this. Was that equal? No, sine squared plus cosine squared. 1. Thank you, Troy. It's 1. Oh, that's 1. And why is that 1? Because that comes from unit circle, right? Remember the unit circle? What was x? X was cosine. Y was sine. X squared plus y squared equals 1 squared, right? That was their equation of circle. Also, the fact that it's following Pythagorean theorem too, right? X, y, and 1, x squared plus y squared, or cosine squared plus sine squared, right? So anyway, that's all 1. So now I get 2 plus 2 sine theta, because 1 plus 1 is 2. Or all this junk. Okay, I'm feeling better about this. I think I see the light at the end of the tunnel. Remember, the other side is 2 secant theta. So I needed 2 for sure. What can you do with the top? What can you factor out? You have 2 plus 2 sine theta. What can you factor out? Come on, you guys. What 2 plus 2 sine theta? What can I factor out? 2. Thank you. And do you see something that goes away? So I want that to go away because I don't see 1 plus sine theta on the other side. I know the 1 plus sine theta has to go. And I know cosine on the bottom is a secant. And now I got it. 2 secant theta. And now it's verified. That was definitely a more labor-intensive one. But I think to get kickstarted, I think you guys should realize, yeah, I got 2 fractions to make it 1 fraction. You guys have done fraction arithmetic for a long, long time, especially with rational functions. So you should be pretty comfortable with that. And then if you just FOIL and use your identities, you should be fine. Things should work out. And of course, factoring as well. And it's verified. Okay, I know it's a little messy. I just kind of jumped around a little bit. Okay, I think that's good enough. I was going to do 30, but I think I'll leave 30 for you guys to do. So, and the other ones as well. All right, we should talk about matrices just for a little bit. Just make sure you guys are cool with matrices. Some of that would be in the calculator portion. Give me a sec here. Now, I do want to do another trick question as well. Hold on. We're not doing Gaussian elimination on the final. Actually, we're supposed to have a quiz. I'm gonna put in schools. You have the quiz tomorrow, but you can do it Friday also. Just so you know, you do it Friday also, or Thursday. So you'll have 3 days to do the quiz. So I'm not gonna quiz you on Gauss Jordan. Let's do. Hold on, I'm still trying to find a good one here. Give me a sec. Okay, it's going to involve a determinant. I'll tell you that. I don't quite see the way we're doing on the final on this review guide, but let me do 58 because that will involve a determinant. And by the way, we will give you this formula. You don't have to memorize this, but I think what you just need to recognize how to locate. Well, first of all, what is a determinant and how to locate it in the calculator. So the formula for area of a triangle is this. We will give this to you guys, by the way. You don't have to memorize it. Okay, cool. So that's, just plug and chug. Now the determinant's a matrix operation, and here's how you access in the calculator. And it's a recording, so you guys can watch this again if you need to. Actually, in fact, I would suggest that you do watch this again. Okay. Um, you could do this if you hit second x -1, that calls it the matrix menu. You can select determinant. And if you hit alpha zoom and define your matrix 3 by 3. And then just type in the numbers 3. Actually, I have a keyboard, so a little easier for me. Gosh darn it.
Wait, alpha zoom?
Yeah, you may have the old operating system. Maybe it's not. No, you have a newer calculator. Should hold on.
Oh, zoom, zoom, zoom.
So, yeah, no worries, you're good. So you get 40. So there the triangle's 1/2 times 40 or 20. Um, to do that by hand is not cool. I'm not gonna make you guys do a 3 by 3 by hand. That would be crazy. And if you think about it, if you were to do a quick sketch, like 3, 9, probably somewhere over here. -2, 4, probably somewhere over here. -5, -7 would be somewhere over here. It's kind of a crazy looking triangle, kind of thin. I mean, if you were to get a little creative, um, hold on. What I'm about to do doesn't make any sense. I'm gonna try to shoot. I think I just made this worse than I maybe. I don't know. Well, maybe this could work. If we're finding the area of this whole thing, I think that would be from -2, from -5 to 3, which is 5, and from -7 to 9, which is 16. So area of the whole thing is 80. For one of the right triangles, that's gonna be 40 right here. Then you have this right here, this little right triangle, which goes from -7 to 4, which is 11, and going from -5 to -2, which is 3. And then from here, from 4 to 9, which is 5, so that's 15. I think I just messed this up pretty hard. Forget about it. So trust me, the answer's 20. Just move on. Okay. I was trying to prove that it works, but it's okay. We don't need to do that. Let's talk about more about trig. Let's do something like angle of elevation or depression might be good. Let's take a look at 45. So, and we'll give you a diagram, don't worry. From a point on the ground, 500 feet from the base of a building, observer finds that the angle of elevation to the top of it is 24 degrees. Angle of elevation to the top of a flagpole on top of it, 27.5 degrees. Find the height of the building and the length of the flagpole. Okay. So here's the building. Here's the ground. Here's the observer. Little stick figure. Here's the flagpole. So what's this angle right here, guys? What would that be? Hmm? Good. And then how about the pink angle? 27.5, right? Okay, good. And then this, of course, is 500 feet from here to here. Okay. So we want the height of the building. I'll call this B, the building. And I'll call this F for flagpole. Okay. What do I do, guys? How do I solve for B? What would I do? What trick function can I use to solve for B? Oh, totally. Thank you, Alex. Perfect. Good. So I'm going to say the tangent of 24 degrees equals B over 5. I trust you can do the rest after this. I don't need to solve it. Once you get that, then what's the next equation I'm going to make?
Um, 5.
Yeah, you're going to say tangent of what? Sorry? No. After you solve for B, how would I make another equation? But for 27.5 degrees, right? And that's going to equal B plus F over 500. And you'll already have solved for B already, right? And then you get F after that. So I trust you can be fine there too. So cross multiply, work it out. All should be good. Okay. Hold on. Still a couple more I want to talk about. Let me pause the recording one more time. Recording. Okay, bearings. Bearings are kind of a funny one. And I have to admit, I sometimes forget how this works too. The bearing question, by the way, for 41, doesn't make any sense. Makes no sense. So you have to cross that one off, actually. I believe we have another bearing one. I hope so. Kind of for 46. Well, I may have to make one up. I may have to pull up one. Yeah, from our old stuff. So hold on a sec. Yeah, here we go. Okay. So here's how this works. This is not in this review guide. The course for a boat race at point A starts at point A, proceeds in a direction. So you're pointing south and you're going 52 degrees west. So remember, south is down, right? And if you're going 52 degrees west, you're going this way west. Then here, also going south, but you're going 40 degrees east. So that's 4 degrees right there. 4 degrees in the eastern direction. And that's point C. This is point A, by the way. That's point B. So if I make a triangle, the triangle's gonna look like this, right? A, B, C. What's this thing over here, guys? What was that? 92. Perfect. Good. Excellent. And you're told that point C lies 8 kilometers directly south. Wait, hold on a sec.
89 or 88.
88?
And 20.
No, I did 40 plus 52, right?
Oh,
Right? I know, unless I'm wrong. I don't know. Let me know.
Yeah.
Okay. Point C lies. Um, okay, so hold on. That seems confusing. Wait. Hold on a sec. Okay, uh, wait, why am I confused here? Let me look at the ants key. That doesn't make any sense. Hold on. Because I feel like we need a distance. Unless I'm missing something here. 50 degrees, 8. Oh shoot. Okay, wait, what? Wait, it doesn't make any sense. You're pointing south and going 52 degrees west. Something seems off here. And I don't know why. Oh shoot. Okay, no, I got that right. 52 degrees west. Oh shoot. Okay. I drew the diagram wrong. Okay, let's restart. My bad. I know I did wrong. I got it. Okay. So here's point A. And point C is directly south of it. Okay, so I should have done that first. My bad. That's 8. My apologies. Okay, redo. Okay, I was right by bearings. That I was not wrong about. Okay, so you're pointing south and going 52 degrees this way. So I was totally right about that. That was correct. Here's B. Now it was from B to C. That was my mistake. I did from A to C. So I didn't read it carefully. That was my fault. I'm glad I did that. So you guys don't make that mistake in the final. Because it says then from B. I will be more clear. Then from B to C. That's what I should have said. So you're going south and going east 40 degrees. Okay, so actually, Timmy, you were right. There was an 88 involved. You were correct. Yeah, because we're pointing south and going 40 degrees east, and that's 50 degrees right there. And then that means that this would be 38 actually.
Oh,
Yeah, so that becomes 88. Yeah, because that's what happens. Because if that's because this is 50 right here, and this has to be 38 right there. So total that's an 80, that's 88. Making that 40 degrees. No, sorry, making that 40 degrees. That's correct. So 40 degrees right there. So that's a little tricky, but that's what happens there. Also, it's also the fact that you have parallel lines as well. So those are also the same. So let me draw it a little nicer because that's a little hard to read. Okay. Now at this point, hopefully you guys remember what to do. You have to use law of sines to do this. So if you're trying to find the complete distance of the race course, you do like sine of 88 degrees over 8 equals, say, sine of 4 degrees over, we'll call this little c. And I trust you guys can do the rest. Just find the calculator. And then sine of 88 degrees over 8, we'll call this little a, equals sine 52 degrees over a. That's what you do after that. So, okay. Sorry I messed that one up initially. And the last one I said finance, right? So let's look at a finance problem. Well, that's interesting. I don't know finance problems. That's very interesting. Oh, there is. Sorry. Okay. I was like, what? Okay. So again, I'll find out if we give the formulas for this. But if you're compounding monthly, first of all, in general, an exponential function always takes on this form, right? Generally speaking, that's what we expect, right? A is the initial amount. So how much are you starting with? Okay, now the B part's a tricky part. Because that's going to be what you're going to be multiplying to the money every year or every month or whatever. The rate's 4.25 and it's growing, right? So usually we think of B as 1 plus R or 1 minus R. I'm going to think it's more like 1 plus R because my money's growing, right? Because you're adding a percentage to 1. Because 1 is 100% and now you have more than 100% of your money. You have 104.25%. But this money is not done every year. It's done every month. So all I'm going to do is 1 plus R over 12. You got to split that percentage because an annual percentage split monthly. There's 12 months in a year. Hopefully that is intuitive. So I know we get so caught up with formulas, right? And the thing is that if T is time in years, but you're applying this percentage 12 times a year. So I can put 12T. So if T is 1, we apply this percentage 12 times. Now you got your formula. You did it intuitively. That's all. And then you just plug it in. It's not that hard. If you want to triple your money, you want 1,500 equals 500. 1 plus 0.0425 over 12. Sorry, my handwriting stinks here. Raised to the 12T. And you got to solve for T. And to solve for T, you have to use logs. So 3 equals, yikes. 1 plus 0.0425 divided by 12. Okay, cool. So it's 1.0035. That's kind of crazy. Nice to do a log of it, you know? And then, punch in the calculator, work it out, you get the answer. And then repeat it for B, but you want to quadruple the money, so you want $2,000. So I put 4 instead of 3. So that's all. Okay. So hopefully that is a nice little review. I'd watch these again. I do problems similar to these. Like 69 might be a good one because that's an exponential problem. There are other log equations, other identities to do, other trig word problems. So this is how you can at least do that. Tomorrow we'll do the same thing for the graph and calculator part. So let me stop the recording.